We have seen all the details of the recipe we propose, the plan of activities and deliverables, the grading system, and 3 additional issues to be considered. However, before starting to plan the activities, we recommend you to answer 8 key questions to prepare the recipe. Just as in any other recipe, we first prepare the ingredients. So these 8 key questions will allow us to prepare the ingredients for the recipe. I will give you 2 examples of what could be the answers to these 8 key questions in 2 different cases. The first example corresponds to an introductory subject on computer programming. The first key question is, what is the potentially sellable product? And what are the product criteria, the product quality criteria? In our example, the product is a computer program that must perform a series of functions related to the management of customers of a business, registration, deletions, and modifications of customer data. It is not very difficult to present this product to students as a necessity of many companies that manage customer data. And it is not difficult to make in class demonstrations of similar products made by students from previous courses, which, as we know, will increase their motivation. The quality criteria for a product like this are basically the following. It must be complete, that is, must perform all the intended functions. It must be robust, that is, not fail even if the user makes a mistake. It must be friendly, easy to use, and good organized and documented, with enough comments in the code so that other programmers can make changes and improvements. These are typical quality criteria for computer products of this type. The second key question is, what do the students know before starting the project that can be used during the project? In our example, we assume that the project takes place in the second half of the course, when students already have learned basic computer programming skills using other techniques, other teaching methodologies. Specifically, they have already learned basic data types and structures, vectors, conditional and iterative statements, basic traversal, search, insert, and delete algorithms. The third key question is, what new knowledge will be acquired by carrying out the project? Remember that this knowledge must be organized into 3 blocks that can be studied autonomously and independently. That is the red, blue, and green blocks of the figures in previous videos. In our example, the 3 blocks are files, data structures, and functions. We use to explain these topics in class, one after the other, so that when explaining, for instance, functions, we use what they have learned already in the explanation of data structures. When applying the recipe, we had to prepare 3 independent sets of self-study materials so that each student can learn one of the blocks without knowing anything about the other 2. Now, for example, in the material on functions, there are no reference to data structures. which is discussed in another independent material. Many colleagues find difficult this step of identifying 3 independent blocks in a syllabus that has always been sequential, in which the explanation of a topic is based on what has been learned in the previous one. Our experience is that this is not actually a particularly difficult challenge. The fourth question is, what are the requirements of version 0 of the product? Let us remember that this version 0 must require the integration of a part of the contents of the 3 blocks of knowledge. In our example, version 0 is a computer program that performs only part of the expected functions. This version 0 must already satisfy the quality criteria, must be robust, friendly, and well organized, and requires the application of knowledge about files, data structures, and some functions to carry out operations required in version 0. Let us remember that when the time comes to develop version 0, the 3 members of the group must work together side by side, so that when the knowledge about files, for instance, has to be applied, the student who is an expert in that topic is not far away and can lead the exercise in that phase, helping his teammates to better understand the topic by seeing it in action. Question number 5 is, what are the 3 individual extensions which, added to version 0, will give rise to version 1? In our example, these are the 3 individual extensions. Number 1, expand the data of a customer, adding the age, the balance, something like that, and rewrite the function to load the data from a file, and incorporate a function, a new function, to save the customer data in a file. This would be the individual extension number 1. Number 2, add 2 new functions, one to register a new customer and to delete a customer. And the third extension would be to add another 2 functions. One to show the data of the oldest customer and show the data of all customers with a balance greater than a given one. So 3 tasks, every student must be responsible for one of them. A little bit more of every block of knowledge, but now every student must put it in practice individually. This is question number 6. What needs to be added to version 1 to get version 2? This is the easiest question of all. A general answer valid for all cases can be this. Add the improvement suggestions that the teacher has made to version 1, and then add any additional requirement. In this case, the additional requirement could be, for instance, add to the information of each customer a list of products that they have bought. For each product, consider the product name and the price. And another thing to be included in these additions to version 1 could be that. Add everything that the teams wants to add to surprise their teacher with the best final result. This is the key question number 7. What is an example of a final individual exercise through which all students are going to show us that they have been involved in the development of the product? In this example, this exercise consists of incorporating one more piece of information to each customer and adding a function that uses that piece of information. To solve this, every student must demonstrate that he knows how to modify the file and the data structure, that they know how to modify the corresponding functions, and that he knows how to implement a new function that performs the additional operation. It is impossible to solve this exercise well if the students does not know the program that the team has made. And the last key question, what are the unforgivable basics which will be examined individually? In this case, the student will have to demonstrate in an exam that he knows how to design a simple data structure, to write the code necessary to open, read, write, and close a text file and detect any error that may occur, that he knows to implement correctly the code of a function that performs a traversal or a search or an insert in the vector of the structure, and that he can write a main program that correctly performs calls to those functions by passing the corresponding parameters and collecting the results of the function. This knowledge can be acquired by studying the book, but the students will acquire it by doing the project, because this is the things that they are going to do during the project. But they will have to demonstrate this knowledge in a different context, which will be an exam with standard exercises in which the data structure will not be a list of customers as in the project, but will be, for instance, a list of books. Okay, so these are the four basic knowledge, unforgivable knowledge associated to the activity.